The Sage Wall in Montana is a fascinating discovery that has captured the attention of paleontologists and fossil enthusiasts.
It's explained away as a dike or a geological formation, but it has a lot of different features to it that are not typical of dikes.
Discovered in 2001 by a team of paleontologists led by Dr. Sarah Johnson from the University of Montana, this significant find was actually stumbled upon by accident. The team had been investigating a nearby site known for its dinosaur fossils. On their way back to base camp after a long day of excavation, one of the team members, Dr. Mark Stevens, noticed an unusual rock formation partially exposed on a hillside. Upon closer inspection, they realized they had uncovered an extraordinary fossil-rich formation. Located within the Judith River Formation in the state of Montana, the Sage Wall sits in a region known for its abundant deposits of late Cretaceous fossils. The exact coordinates of the Sage Wall are kept confidential to protect the site from vandalism and unauthorized fossil collecting, but it is situated near the Missouri River. This picturesque backdrop adds to the allure of this significant paleontological site.
If you're in the area or you want to see something which is mind-blowing, come to this site.
Absolutely.
This is incredible.
The Sage Wall dates back approximately 75 million years to the late Cretaceous period, an era characterized by a warm climate, high sea levels, and the dominance of dinosaurs on land. During this time, the area that is now Montana was part of the Western Interior Seaway, a vast inland sea that split North America into two landmasses, Laramidia to the west and Appalachia to the east. This seaway played a crucial role in the geological and ecological dynamics of the region. This natural rock formation is primarily composed of sandstone and mudstone, which were formed through the deposition of ancient river sediments over millions of years. These sediments were carried by ancient rivers and streams from nearby mountainous regions, accumulating in layers that were eventually compressed and cemented into solid rock through the process known as lithification. The Sage Wall itself is an impressive geological structure, standing approximately 50 feet high and extending about 200 feet in length. The individual stones within the wall vary greatly in size, with some large blocks weighing several tons. These massive stones were likely transported by powerful ancient river systems, moved by significant water flows during periods of heavy rainfall or seasonal flooding. This site is particularly noted for its high concentration of dinosaur fossils. Additionally, the site has yielded significant plant fossils, providing insights into the ancient ecosystem of the late Cretaceous period. Key discoveries include a nearly complete juvenile hadrosaur skeleton and a small theropod with evidence of feathers, offering valuable information on dinosaur diversity, behavior, and evolution. The Sage Wall, while impressive in its structure, is a result of natural geological processes rather than human construction. The orderly deposition of sediments and the presence of natural cementing minerals align with known natural geological activity over millions of years, emphasizing its natural origin. While the Sage Wall's impressive structure might suggest a man-made or even mythical origin, such as being built by giants, all evidence points to it being a natural formation.
It could simply be totally natural, a freak of nature, so to speak. But part of me, when I first look at it, that gut impression is like, oh, come on, this has to be more than just natural.
The layering, composition, and fossil inclusions within the wall align with known geological processes that occur over millions of years. The orderly deposition of sediments and the presence of natural cementing minerals indicate that the wall is a product of natural geological activity, rather than human or mythical intervention. The Sage Wall is famous for its hadrosaur fossils, which include numerous bones and teeth. This specimen, along with others, underscores the importance of the Sage Wall as a window into the past, offering a detailed look at the ancient life that once thrived in what is now Montana. The Sage Wall has also yielded fossils of horned dinosaurs, such as ceratopsians. These fossils include skull fragments, horns, and teeth, offering insights into the anatomy and behavior of these herbivorous dinosaurs. The discovery of theropod fossils, including relatives of Tyrannosaurus rex, has added to the site's significance. These fossils include bones and teeth, which help scientists understand the predatory habits and evolutionary relationships of these carnivorous dinosaurs. One of the most exciting discoveries at the Sage Wall is the fossilized remains of a small theropod dinosaur with evidence of feathers. This find has contributed to the understanding of the evolution of feathers and their role in dinosaur physiology and behavior. Additionally, plant fossils found at the Sage Wall include well-preserved leaves, seeds, and petrified wood. During the late Cretaceous, the area where the Sage Wall is located was a lush, subtropical environment with rivers, forests, and abundant wildlife. This contrasts sharply with the semi-arid climate of modern-day Montana. The region supported a diverse range of plant life, including conifers, ferns, and flowering plants, which provided food and shelter for a variety of herbivorous and carnivorous dinosaurs. An interesting comparison can be made between the Sage Wall and the famous Dinosaur Provincial Park in Alberta, Canada. Both sites are rich in late Cretaceous fossils and provide valuable insights into the ecosystems of that time. However, while Dinosaur Provincial Park is known for its wide variety of dinosaur species, the Sage Wall is particularly noted for its exceptionally well-preserved fossils and the evidence of possible nesting sites. Another fascinating comparison is with the Hell Creek Formation, also located in Montana. Both sites are rich in late Cretaceous fossils and provide valuable insights into the ecosystems of that time. While the Hell Creek Formation is known for its diverse array of dinosaur species, including the iconic Tyrannosaurus rex and Triceratops, the Sage Wall stands out for its exceptional fossil preservation and the potential evidence of dinosaur nesting sites. This comparison highlights the unique contributions of each site to paleontology. One intriguing theory arising from the study of the Sage Wall is that the area may have been a nesting ground for certain dinosaur species. Evidence supporting this theory includes the discovery of nesting sites, eggshell fragments, and juvenile dinosaur fossils. The presence of these fossils suggests that the Sage Wall region provided a suitable environment for raising young, with abundant vegetation for food and protection from predators. This theory offers valuable insights into the reproductive behavior and life cycles of dinosaurs during the late Cretaceous period. This leads us to another fascinating paleontological site, Dinosaur Provincial Park in Alberta, Canada. Located about 48 kilometers northeast of the town of Brooks, the park sits within the Red Deer River Valley, known for its striking Badlands topography. Designated a UNESCO World Heritage Site in 1979, the park is celebrated for its outstanding paleontological significance, scenic landscapes, and diverse ecosystem. The rock formations in Dinosaur Provincial Park date back to the late Cretaceous period, approximately 75 to 77 million years ago, marking the tail end of the age of dinosaurs. The park features a variety of sedimentary rock layers, including sandstones, shales, and mudstones. These layers were deposited by ancient rivers and deltas, creating a rich tapestry of geological history. With over 500 dinosaur specimens removed and displayed in museums worldwide, Dinosaur Provincial Park is one of the richest dinosaur fossil locales on the planet. The park has yielded fossils from over 40 different species of dinosaurs, representing a broad range of the dinosaur clade, including both herbivorous and carnivorous dinosaurs. In addition to dinosaurs, the park has provided fossils of other prehistoric creatures, including fish, turtles, and early mammals. Plant fossils are also abundant, offering insights into the ancient ecosystems that once thrived in the region. During the late Cretaceous, the area that is now Dinosaur Provincial Park was a lush, subtropical environment with rivers, lakes, and floodplains, supporting a diverse range of plant and animal life. The climate during the late Cretaceous was warmer and more humid than today, contributing to the rich biodiversity of the region. One of the most remarkable features of Dinosaur Provincial Park is its extensive bone beds. These areas contain large numbers of dinosaur bones, often representing mass mortality events. The Centrosaurus bone bed, for example, contains the remains of hundreds of individuals, providing a snapshot of a moment in time and offering an incredible window into the past. Deep within the dense forests of New Zealand's North Island lies the Kaimanawa Wall, a structure shrouded in mystery and controversy. With its precisely aligned blocks that mimic the handiwork of an ancient stonemason, this wall challenges the conventional timeline of human history in New Zealand. Could this be the remnants of a lost civilization, or simply an incredible feat of natural geology? Or was there another creator of these walls we don't know about? As debates continue and theories abound, the Kaimanawa Wall invites explorers and scholars alike to delve into its mysterious presence, potentially rewriting history with each new discovery. In the 1990s, an unexpected discovery by helicopter pilot Barry Brailsford dramatically shifted the focus of historical and archaeological exploration in New Zealand. While flying over the dense, rugged terrain of the Kaimanawa Ranges in the central part of the North Island, Brailsford spotted an unusual formation. From his aerial vantage point, this formation was clearly visible as a series of large, neatly arranged stone blocks. Their unusual and striking regularity, characterized by straight lines and precise angles, made them stand out distinctly from the natural ruggedness of the surrounding landscape. This area of the Kaimanawa Forest Park is quite remote and not easily accessible on foot, which likely explains why the formation had remained unnoticed by ground-based observers. Recognizing the potential significance of his find, Brailsford took decisive steps to ensure that both the public and the scientific community became aware of the formation. He began by capturing photographs of the wall. These images were crucial for documenting its characteristics and facilitating the initial assessments by geologists and archaeologists. Understanding the broader implications, Brailsford also reached out to local media outlets, sharing his findings and the intriguing images of the wall. This proactive engagement with the media was instrumental in sparking widespread interest and debate about the nature and origins of the wall, bringing it into the public eye and making it a subject of fascination and controversy in equal measure. The Kaimanawa Wall and its peculiar features bear a striking resemblance to ancient megalithic structures, sparking a lively debate about its origins, whether it's a product of natural geological processes or an artifact of an ancient civilization. The wall is remarkable for its orderly assembly of large rhyolite blocks. These stones are not only uniform in size, but also exhibit geometric precision with their straight edges and sharp angles, characteristics that are uncommon in natural rock formations, which typically show more random and varied profiles. The wall stretches approximately 30 meters in length and stands about 2 meters high. Each block is nearly identical in size, which varies slightly, but stays within a narrow range, suggesting a level of precision that is either a remarkable act of nature or evidence of human craftsmanship. To understand more about this mysterious structure, detailed geological surveys have been conducted at the site. These involve analyzing rock samples and the structural composition of the wall to determine the type of rock, its age, and the possible geological processes that could have led to such a structured appearance. The findings reveal that the wall is composed of rhyolite, a volcanic rock prevalent in the Taupo volcanic zone. Rhyolite can fracture naturally in straight lines, particularly under conditions where the lava cools uniformly and slowly. The uniform and angular disposition of the blocks at the Kaimanawa Wall is consistent with certain types of natural stone fracturing processes, known in geology as jointing, which can create angular and straight fractures. Most geological assessments classify the Kaimanawa Wall as a natural formation, primarily because of the natural occurrence of columnar jointing in volcanic rocks, similar to rhyolite. This process can result in formations with surprising geometric regularity, akin to those found in well-known sites like the Giant's Causeway. The debate continues, however, as these compelling comparisons and scientific analyses deepen the mystery, leaving room for different interpretations and ongoing research into this megalithic structure. The Giant's Causeway, nestled on the northeast coast of Northern Ireland, serves as a stunning natural wonder of the world and provides an interesting point of comparison to the mysterious structures of New Zealand's Kaimanawa Wall. Renowned for its roughly 40,000 interlocking basalt columns, the Giant's Causeway was formed about 50 to 60 million years ago during the Paleogene period. This unique formation occurred when a volcanic eruption caused highly fluid lava to spread across a large area. As this lava cooled, it contracted significantly, particularly at the surface, which cooled more rapidly. This contraction led to the formation of vertical cracks that ultimately shaped the distinctive hexagonal columns that are so characteristic of the causeway. Interestingly, while most of these columns are hexagonal, they can have anywhere from 4 to 8 sides. The columns vary in height, with the tallest reaching about 12 meters and diameters ranging from 15 to 25 centimeters. Beyond its geological significance, the Giant's Causeway is also a UNESCO World Heritage Site, celebrated for its natural beauty and its contribution to geological research. This site is particularly valued for its classic example of columnar jointing, offering vital insights into volcanic cooling processes. It acts as a crucial natural laboratory for geologists who study these phenomena and has played a pivotal role in confirming theories regarding the cooling rates and contraction forces of basaltic lava. The site is also deeply embedded in local mythology and folklore, most notably through the legend of Finn McCool, an Irish giant. According to legend, Finn built the causeway to reach Scotland and confront another giant. When he saw the immense size of his opponent, Finn retreated. His wife then cleverly disguised him as a baby, tricking the Scottish giant into believing that if the child was so large, the father must be truly colossal. Frightened by this prospect, the Scottish giant fled, destroying the causeway behind him to prevent pursuit. Turning to the Kaimanawa Wall, while it shares the feature of symmetrical stone patterns with the Giant's Causeway, its origin sparks more debate. The discussion oscillates between natural geological processes and possible human construction, unlike the clearly natural origins of the Giant's Causeway. This situation highlights how similar geological phenomena can manifest under vastly different conditions and interpretations, showcasing the complexities and wonders of Earth's geological diversity. This comparison between two such diverse geological formations underlines the intricate ways in which natural forces and, potentially, human influences intertwine to shape our understanding of the world's ancient landscapes. Another reason to believe the Kaimanawa Wall in New Zealand could have been man-made is by looking at the Inca walls in Peru. They both represent two fascinating yet starkly different types of stone constructions, each with their own unique characteristics, construction techniques, and surrounding theories. The Inca walls, notably at sites like Sacsayhuaman and Ollantaytambo near Cusco, demonstrate an exceptional level of craftsmanship in stone masonry. The Incas utilized a technique known as ashlar masonry, where large stones are meticulously cut to fit together tightly without any mortar. The precision of this stone cutting is so remarkable that not even a blade of grass can fit between the stones. This technique not only provided structural stability but also enhanced the wall's resistance to earthquakes, a common threat in the Andean region. These walls are not just functional, they hold significant cultural importance, reflecting the Incas' sophisticated understanding of architecture and their deep connection to their environment. The alignments of the walls with celestial events like solstices and equinoxes underscore their importance in Inca religion and agricultural practices. The precise methods used by the Incas to shape these stones remain a subject of debate among archaeologists. Some theories suggest the use of tools made from harder stones or bronze, while others propose techniques that involved heating the stones and then rapidly cooling them with water to create fractures. In contrast, the origin of New Zealand's Kaimanawa Wall is shrouded in debate. While some suggest it might be a natural geological formation resulting from the regular fracturing of volcanic rock, specifically rhyolite under certain cooling conditions, others speculate about its potential as a man-made structure. A key point in this debate is the absence of tool marks, which are clearly visible on the Inca walls. This supports the theory that the Kaimanawa Wall's formation might be natural rather than crafted by human hands. The unusual regularity and symmetry of the stones at the Kaimanawa Wall, while rare in natural formations, are not deemed impossible by geologists. Similar formations have been noted in other parts of the world where columnar basalt or other fracturing patterns have occurred due to volcanic activity. The Inca walls are undeniably the result of intentional, skilled labor, showcasing advanced techniques in stone cutting and construction. In contrast, the Kaimanawa Wall, if a product of natural geological processes, represents an intriguing example of how natural forces can mimic the appearance of intentional construction. While the Inca walls were integral to the social and religious fabric of their creators, built to last and to impress both the gods and future generations, the Kaimanawa Wall's significance lies primarily in the mystery of its origins, whether it is a remarkable natural geological artifact or evidence of a forgotten civilization. The Kaimanawa Wall, if confirmed to be man-made origins, could radically reshape our understanding of New Zealand's prehistoric past. This enigmatic structure could suggest the presence of an advanced pre-Maori civilization, challenging the currently accepted timeline of human settlement in the region. Such a revelation has significant implications, not just for archaeologists and historians, but for the entire narrative of New Zealand's history. Over time, the wall has woven itself into the fabric of local lore and speculative histories. Various non-mainstream historians and enthusiasts have suggested that it might be evidence of ancient settlers or even lost civilizations. This is similar to the speculative interpretations that surround other mysterious ancient structures found worldwide, where local myths and global intrigue often blend to form compelling tales of forgotten histories. The ongoing interest in the Kaimanawa Wall exemplifies a broader global fascination with unexplained structures. It continues to be a focal point for discussions about archaeological methodologies and the interpretation of ancient sites. This mystery invites a deeper dive into the past, prompting calls from within the scientific community for more comprehensive studies to ascertain the true nature of the wall. Such investigations are crucial, as they not only help clarify the origins of specific structures but also enhance our understanding of the human footprint across different epochs and geographies.